All right, hi everybody. For this lesson, we're going to take our LED circuit and add a photoresistor to it. So the last lesson, we were using a potentiometer to drive the speed of the blinking of the LED, but now we're going to use this photoresistor to control the brightness. So because we're controlling the brightness, we're going to change our LED circuit to use a pulse width modulation pin so that we can go between voltages, not just on and off. And so this is another analog input, just like our potentiometer. But what this allows us to do is to measure the brightness in the room, and then if you put your finger over it, it measures that brightness. So depending on where your hand is in relation to this thing, you can use that as an input into your Arduino. And so let's set it up. So now that our circuits are getting a little bit more complicated, I'm going to move a few things around from the other example. So I have my my black ground cable up here. I'm going to move it to ground, to one of these ground pins. And then I'm going to take my red power cable and do it to 5 volts over here, because that's what we're going to need now. And then this red cable attached to the bottom of the LED circuit, instead of going straight to the red column, we're going to go all the way over here now to pin 9. So now that's what we're going to do from now on. Is if we're trying to get directly to a pin, we're just going to take a cable and go directly to that pin instead of to our columns. Okay. Now, we're going to make a resistor divider network to set up this this photoresistor. So the first thing that we do is put it in like that, so that the legs are not connected. So up and down like this. And then the next thing that we're going to do is put a resistor at the top, between the top leg and then the other leg of the resistor is just going to go somewhere else. So you'll notice that if we compare these two inputs that we had, the photoresistor and this, our potentiometer, this has 3 pins. The top pin is the low voltage, the top pin is the high voltage, the low pin is the low voltage, the middle pin is the pin that you actually send the signal on. And so we're sort of recreating that with the photoresistor that only has 2 legs. And so this bottom pin, this bottom leg is going to go to ground. The middle leg that now has a resistor in the way of it is going to go to the pin that we're sending to, which is going to be A0. And then the top, now we can think of it as the top pin on the potentiometer, which is the other side of the resistor, is going to go to our power, our 5 volts. So let's hook that up. So from here to here with the red cable, we want to sort of keep it, there we go. Actually, over this way. Okay. And then I'm going to use a blue cable, just something that's not black or red, to go from the middle of our of this new circuit. Now to A0, and it's just got brighter because I'd already run the circuit before on Arduino. And in the bottom, we're going to connect to the ground to finish our circuit. Okay. Now I'm going to go to the, and this is the circuit. I'll move it to get a little bit of a better view, but hopefully, hopefully this is clear enough. So over to the Arduino. So instead of typing this all from scratch, we're just going to go through it. We have an LED pin, just called LED, that's pin 9. We have a brightness variable, that's an integer, that we're just going to set at 200. We have a fade amount at 5. Fade, this is actually not getting used, it seems like. And then we have a photo int. And the photo is going to be the variable that you're going to store the incoming photoresistor data on. Okay. So now, I don't think that you actually need this, but we might come back to this because I think that you don't need it with pulse width modulation. So serial.begin, we need this for our serial monitor. So we'll see in a second to be able to monitor the data that's coming in from analog inputs. Serial monitor is really good. So this is how you turn it on. And so we're going to say photo equals analog read A0. We're doing that because we set our blue cable to go into analog A0. And now what we can do is read it. So the way that you send something to the serial monitor is to say serial.println and then the variable. So to read it, I'm going to click over here on the serial monitor button. I'm going to go up, and I'm going to see now we're getting values from 2. You want to sort of look and get some sort of an average out of this. Say it's probably 300. What we're doing now is we're seeing, if I don't touch this, what is the ambient light in the room? And we're getting towards this idea that you need to calibrate the photoresistor depending on what room you're in, because you want to get the lowest light possible, or you want to get like the light when you're not touching it at all, when your hand's not on it, and then you want to get the other range when your finger is entirely on it. And so you might remember the range of our LED is between 0 and 255, but the range that we're getting from this is not close to that, right? We're entirely out of the range, and that's why we're getting some very strange, that's why we're getting a really strange result. So I'm not showing the LED now, but what you should see is not from the lowest to the highest. It's just sort of blinking on and off. Okay, so I'm going to close the serial monitor, and now I'm going to introduce a new function, which is called map. And so this map function is the same as it is in P5 if you use the P5 one, but basically you can take an input, which is the first parameter, and then map it between map it between one range, an input range, which I decided 620 to 870 was my low and high input range. I might have to redo that. And then the output range. So the input range is going to be 620 is the lowest number that I was getting. And so that was probably when the sun was a little bit brighter. So I might need to change that. So let's change it. Let's go back to my serial monitor and see what's the lowest number that I get here. It's like let's just say 620. Wait, 320, 320. And so I'll change that to 320. And then what's the highest number that I get? And the highest number is going to be when I put my finger over this. So now let's give it a 660. And so this is what you need to do to get this to work correctly. 660. And then we know that we're mapping it to the range of 0 to 255, so you don't need to change that. So then I can comment this out. I have a print line down here to say, pseudo that print line brightness, which is the variable that I'm putting this mapping into. So I'm going to load my code. And now we're compiling and uploading. And now I can see, hopefully, that I'm going to get between, I want to see values between 0 and 255. Oh God, okay, I'm getting all these negative values. And I'm getting pretty close to 255, which is good. I like that. But I'm getting all these negative values. And so this is probably because just when you're working with any sort of analog input, you know, it's analog circuitry, so it's not like it's not the most precise thing. Well, and the sunlight is always changing, especially if your windows are open like mine are. So what can we do? We can use this other function called constrain. And so this works a lot like the map. It takes in an input, which is going to be the input is brightness coming from the map function. And then we're going to say, don't go below 0, and also don't go above 255. So this is the minimum and the maximum. If anything goes below there, just cut it off. If anything goes above 255, also cut it off. So now I'm going to load it again. And then I'm going to check the serial monitor one more time and just hope that everything looks good. Done uploading. So the lowest that we get is 0. That's good. Okay, we're not getting all the way up to 255. So let's give it like an 800 here. So if your windows are open, this might be sort of a fool's errand to try to keep going. Oh, that made it worse. But that's okay. But so you might want to close your blinds, but now at this point, we can see our analog right function that we're using the value of, well, actually, we don't want to map straight to the value of photo. We want to use brightness. So before I had been using photo just to show you what happens if we don't do any constraining or mapping or anything. Now we want to use the brightness. We're going to write out from the Arduino to the LED pin, which is pin 9. So make sure that it's plugged in to the pulse width modulation pin 9, and the value of the brightness, and then you should get a pretty good result. And yeah, so let's bring it back to so we're back, and I got a pretty good result. My finger's all the way down. I'm getting total brightness. My finger's off. Now I'm getting nothing. So you'll notice that like it could be a little bit brighter if I closed my blinds and I controlled the ambient light in the room. This would work a lot better. Okay, that's all for now. See you next time.